In the vast spaces, a pioneering discovery by the James Webb Space Telescope, JWST, suggests the existence of distant city-like lights that could signal life beyond our planet. Could this be the proof we've been looking for, proof that we're not alone in the universe? Less than 2 years after launch, the James Webb Space Telescope, JWST, has changed our understanding of the universe. Scientists are amazed by the groundbreaking discovery of distant city-like lights captured by JWST 7 trillion miles away. The discovery exceeds expectations, expanding our cosmic understanding and sparking speculation among scientists looking for data on these celestial signs. Could these lights indicate life beyond Earth, raising questions about extraterrestrial civilizations and the likelihood of life elsewhere? Join us and discover how the city captured by JWST illuminates billions of kilometers of our planet. In less than 2 years after launch, the James Webb Space Telescope, JWST, changed our understanding of the universe. For scientists, the images open up new possibilities in astrophysics, while for the rest of us, they are just amazing. Astronomers around the world are amazed by a groundbreaking discovery. JWST has captured distant city-like lights 7 trillion miles away. The discovery exceeds expectations, expanding our cosmic understanding and sparking speculation among scientists looking for data on these celestial signs. The discovery points to life beyond Earth, raising questions about extraterrestrial civilizations and the likelihood of life elsewhere. Join us and discover how the city captured by JWST illuminates billions of kilometers of our planet. Launched on Christmas Day 2021, JWST aims to be an improved and more powerful imaging device than the Hubble Space Telescope. Its purpose is to obtain the sharpest images of newly identified objects, such as planetary systems. Before diving into the latest discoveries, let's look at the role of the Hubble Space Telescope in space exploration. Launched in 1990 and still operating, the Hubble Space Telescope, HST, revolutionized astronomy. A joint effort between NASA and the European Space Agency, ESA, is realizing a dream of the 1920s made possible by technological advances in the 1970s. The main mission of HST is to provide high-resolution cosmic images that allow detailed studies of celestial bodies and deepen our understanding of the formation and evolution of galaxies, stars, and planets. Like a Cassegrain mirror telescope, HST achieves focusing of light from space objects using mirrors. Its 2.4-meter, 7.8 feet, primary mirror, along with a smaller secondary mirror, directs light to a focal plane that contains the means for image capture and data collection. Hubble is equipped with various instruments that support various observations of the universe. These include cameras that take pictures of space objects, spectrographs that separate light into its primary colors for analysis, and polarimeters that study the polarization of light to identify the properties of celestial bodies. Hubble's design also includes astronaut maintenance capabilities, allowing for repairs and instrument upgrades. During the first maintenance work in 1993, the defect of the primary mirror was corrected by attaching correction optics. A total of 5 maintenance missions have been completed, the last of which was in 2009. The Hubble Space Telescope forever changed our view of space, providing stunning images of celestial bodies and making amazing discoveries. These include measuring the expansion rate of the universe, detecting dark energy, and tracking the birth of stars and galaxies. Hubble's legacy extends beyond discoveries, promoting innovation in astronomical technologies and inspiring new generations of scientists. The success of telescopes like JWST builds on Hubble's legacy, promising a deeper view of space and advancing our knowledge of the history of the universe. JWST Deep Field Images aim to study the oldest galaxies and date the age of the universe to its earliest stages. Using the solar system as a tool, JWST will image celestial objects as their ancient ancestors may have seen them. Astronomers use light years, the distance light travels in 1 year, to determine these immeasurable distances. JWST's first presentation highlighted the concept with a deep field image launch by President Joseph Biden at the White House on July 11, 2022. Reminiscent of Hubble's deep field images, this image zoomed into a small patch of sky and classified about 3,000 new objects, mostly distant galaxies billions of light-years away. The JWST deep field image, like the Hubble image, shows a seemingly insignificant blob in the night sky. However, There is much information to be mined in this small region near the SMACS 0723 galaxy cluster. Located about 4.6 billion light-years away, this colossal cluster acts as a natural magnifying glass thanks to its immense gravity. This phenomenon, known as gravitational lensing, allows astronomers to dive deeper into the past, reaching up to 13.1 billion light-years. The focus on the unknown extends to the search for life beyond Earth. The large number of distant galaxies revealed by JWST has sparked new scientific research, especially regarding a certain Earth-sized planet that may hold clues to the existence of extraterrestrial life in our cosmic neighborhood. This effort addresses the Fermi paradox, which questions the lack of evidence for advanced extraterrestrial life despite the high probability of its existence. One star system of particular interest is TRAPPIST-1, located approximately 40 light-years from Earth. This star system, which has 7 Earth-sized planets around it, is central to the search for habitable worlds. NASA considers various parameters such as size, distance from the host star, and atmospheric composition to assess a planet's potential to support life. JWST recently achieved a milestone by measuring the temperature of TRAPPIST-1b, the first detection of light emitted by an exoplanet of its size and temperature range. This success highlights the sensitivity and potential of the telescope to change our understanding of the atmosphere of the rocky planet. While JWST explores distant worlds, Voyager's missions continue to amaze scientists closer to home. Voyager 1, launched in 1977, is now encountering a mysterious region at the edge of our solar system. This unexpected journey adds another chapter to the great history of the Voyager missions. Originally designed for short missions, the Voyagers provided an enormous amount of valuable data and expanded the study of space science. These observations constantly remind us of the endless importance of curiosity and exploration. According to scientists, interstellar space begins where the sun's magnetic field and solar wind stop. Voyager 1 reached this milestone in 2012, while Voyager 2, 11 billion miles from Earth, reached the region in 2018. Interestingly, Voyager 1's new discoveries reveal surprising phenomena at this boundary, known as the heliopause. These phenomena include plasmas and high-energy particles that challenge previous assumptions. This understanding has led scientists to conclude that the heliopause, far from being a well-defined boundary, is a dynamic, ever-changing region affected by various factors both within our solar system and in the galaxy beyond. Despite technical difficulties and the harsh realities of space, Voyager 2 continues to produce valuable scientific information thanks to innovative solutions developed by NASA engineers. It is a constant reminder of humanity's constant desire to venture into the unknown, fueled by curiosity and the search for knowledge. In our solar system, Venus has also become a new point of interest after previously being considered unattractive due to its extreme heat. Recent observations by astronomers have revived scientific curiosity about Venus. The discovery of phosphine gas in the Venusian atmosphere, a gas often associated with biological processes, prompted scientists to reinvestigate the planet. Although phosphine is produced by microbes on Earth, scientists are careful to avoid jumping to conclusions when considering other possible sources. The search for life on Venus examines complex aspects such as chemical reactions, planetary evolution, and possible alternative biological processes. Venus history also hints at a warmer past, perhaps with liquid water for billions of years, drawing parallels with Earth. This similarity raises interesting questions about whether life once existed or could still exist in the harsh environment of Venus. Unlike the scorching heat of Venus, the icy surface of Jupiter's moon Europa is also a candidate for shelter. An underground ocean, hidden beneath this thick ice sheet, increases the possibilities for life in extreme environments. The sheer distance of these background galaxies extends the light they emit, changing it from the visible spectrum into the infrared region. This change allows JWST, which is specially designed to detect infrared light, to observe these ancient galaxies with exceptional clarity. By comparing these observations with visible images from a telescope like Hubble, astronomers can piece together a grand story of galactic evolution. This comparison provides a unique window into how galaxies evolved from their primordial state billions of years ago to the majestic structures we see today. One particularly impressive aspect of the JWST Deep Field image is the speed with which it was acquired. Remarkably, the telescope captured so much data in a few hours, proving its exceptional efficiency in detecting galaxies. Furthermore, the magnifying power of gravitational lensing is not limited to galaxy clusters. JWST also captured a fascinating image of two interacting galaxies known as VV191. As light from one galaxy passes through the other, it becomes distorted, providing clues about the dust properties of the intervening galaxy. This newly discovered information may reveal new secrets about the composition and evolution of galaxies. JWST's reach extends beyond the study of distant galaxies. A recent mystery published on the official website suggests the possible discovery of the aurora borealis on a brown dwarf, a celestial body located between the stars and planets. This finding is surprising because brown dwarfs lack the internal fusion processes that power stars and produce auroras. Scientists are working to determine the exact source of the energy.